And for the third section of 10.7, I'm going to go to black here. 10.7C. Oops. 10.7C. We're going to take a look at the area of a segment. Now, what I said on the last one was you take the area of a sector. Now, remember, that was if we called this A and B, that would be the measure of arc AB over 360 times pi r squared. Either one of these radiuses from the center point to A or the center point to B would be the radius, and that would give us the area of a sector. Now, minus the triangle, a little harder here to find. It's 1/2 times, let's go with small b, base times height, okay? Height in this case would be a measure that would be splitting this, and I'm not doing very well with that. There we go. That would be height, okay? And it would have to be at a right angle in here, and you would take your base and your height, okay? And the base would be the entire side. So we'd be looking at 1/2 times base times height. And then what's left over, once you found the difference, is called the area of the segment. That's this little piece up here. So we're still using sector. We're taking away the area of the triangle, which we're a little familiar with, but we're going to be looking at 45, 45, 90 right triangles and 30, 60, 90 right triangles. Okay, because we're looking at these as this would be x, x, x rad 2, and then this would be x, double x, and x rad 3. Those formulas will help us in finding the heights and the bases of these triangles that we're going to be looking at. All right, here we go. So we'll start with this first one, the area of a segment of a circle. So we're looking at just this little piece right up here, all right? And what's the area of the shaded segment? So we got to find the sector first, all right? You notice that inside is 60, so our measure for the outside arc would also be 60. To find the sector, okay, we would take 60 over 360, and that would be the portion. And then notice that the radius, r, is 18 inches. Okay? And if it's 18 inches, that would be pi. I don't know what I did there. Okay, I must have hit something on the side of the screen there. Pi r squared, or pi times 18 squared, and that would give me then the sector. Okay, minus, then the triangle is going to be 1/2 times base times height. Well, if this internal angle is a 60, and these two angles here are the same, why? Because their radiuses here have to be the same, these radiuses, so the angles opposite them are the same. If they are the same, and they have to be 120, then it's a 60, 60, 60, or an equilateral triangle, right? So we know that this is 18. That means if I split this in half, this is going to be a 30, and this is a 60, and we have a 30, 60, 90. Now, if they're all the same, equilateral, then all the sides are the same. My base is going to be 18 down here, as AB is that length of AB, not the measure of the arc, but the length of the segment across is 18 as well. Okay, now we got to find this height. The height is a little different. That's this guy right here. All right, so as I'm looking at my triangle, I'm going to take half of 18. That would give me 9 down here. And this is my 18. 9 is my x. So if I'm using x 2x, and x rad 3, this would be 9 rad 3. So we'll take 18 times 1/2 times 9 rad 3. Okay, and that's going to give me half of 18 is 9 times 9 times rad 3 would be 81 rad 3. Half of 18 is 9. 9 times 9 is 81. 81 rad 3. That's going to be the area of my triangle. Well, here we're going to have 18 squared. I believe 18 squared is 324. So I'm going to have 324 pi. And then 60 over 360 is 1/6. So that would take us 324 divided by 6, which gives us 54 pi. Minus, okay, 81 rad 3. Okay, so there's our sector. This is our sector, and this is our rectangle. So, I'm sorry, I said rectangle, our triangle. So we're going to take 54 times pi, which is going to give us 169. Now, I need to get real small on this, so I'm going to go down to about like this. Okay? So, 169.646 minus, and then 81 times rad 3 is going to give me 140. 140.296. And if I subtracted that from the 169, 169.646, then I would get approximately, because we had to round, 29.34988 or 0.35. Okay, and that's going to be in inches squared. So 29 point, get a point there, 35 or 350 inches squared. All right, let's look at the next one. I'm going to make this just a little bit bigger because it's kind of hard to get a dot there. Notice that my radius is 4 meters. Okay, and then my central angle is 90, so my measure of the outside arc, or that arc that matches with it, coincides with it, is also 90 degrees. So the measure of arc PR is 90 over 360 times then the area of the circle, pi r squared. Okay, pi times 4 squared, which would be 16 pi, and 90 over 360 is 1/4. Okay, which gives me 16 over 4 pi, or 4 pi. That's the area of my sector, 4 pi meters squared. All right, now we're going to subtract, and we're going to have to use, that wasn't very good. Let's try it again. We'll go this way. We'll use that height, and this time it's a radius of 4, and since this is 45, 45, 90, our 45, 45, 90 would be x, x, and x rad 2 for the formulas. Okay, and again, this is my 90-degree angle here. Well, my 90 is this one, so this is the x rad 2 over here. So 4 is equal to x rad 2. I want to find x, so if I divide by rad 2, okay, then that would give me x is 4 over rad 2, and if you multiplied by rad 2 over rad 2, you'd get 4 rad 2 over 2, which would be 2 rad 2. And 2 rad 2 is going to be my x. That's my height. So that's this piece in here that I'm having a hard time getting my pen on. So that's 2 rad 2. So it's going to be 1/2 times 2 rad 2 for the height, and the base, which was double that, is going to be or 4 rad 2. Okay, 2 rad 2 times rad 2 would be okay, so this would be 4 rad 2. Yeah, so this would be 4 rad 2. So I'm going to multiply the like parts. That's the rational parts would be 8. 2 times 4 is 8. The irrational would be rad 2, which is rad 4 times the 1/2. By the way, what is half of 8? That's right, it's 4. And what is the square root of 4? Well, that's 2. So 4 times 2 is 8. So I'm going to have 4 pi for my sector minus 8 for my triangle, and that'll give me then the measure of the segment, which is what's left over. And I need a decimal, so this is my area of the segment. Okay, and if I take 4 pi which is 12.566 minus 8. I'm going to get about, because we're going to have to round there, 4.566. The measure was in meters, so that will be in meters squared. There's my approximation, and that's all I can do on this one. Okay? Or I just take 4 pi minus 8 for an exact. All right, that's going to be it. Now, what we're going to do for the rest of the week is, this is Monday's lesson, so we'll have a review tomorrow, or Wednesday, I should say, and a quiz on Friday. That's what's coming up, just to keep you alert. So a 2-day advantage here. We'll review on the Wednesday set, which will give you kind of an upbeat of what's all coming, and then Friday will be a quiz, and it's going to be much in the same fashion of Excel, okay? Hope you're having a great week. If you got any questions, you can get a hold of me through an email or by way of the phone number I gave you in that email last week.